Hi, so I'm Cyprian, and I would want to make a small clip commenting on some mistakes that are more or less misconceptions about programming. And I, as a programmer, I want to make them clear. So, first one.
Windows XP drew heavy inspiration from Windows ME in terms of media features and system tools, but also marked a significant transition as the first version of Windows to be released to both consumers and enterprise users since Windows 3, merging the old 9X line of Windows into the newer and more stable NT line that powers the Windows operating system to this day.
Yes, so this is really wrong. And I'm not wanting to fight the definition of enterprise because people have a different understanding of what enterprise is. But people, for clear, they understood, and Windows XP was not an enterprise tool, was never sold as this. What is true is that many companies would be using a Windows NT part of their enterprise deployment, but this doesn't mean it's enterprise. And what I mean by this is simply that Windows 95 was part of the enterprise deployment in many companies. They were not always using Windows NT workstations. They were fine with Windows 95 or Windows 98, especially for the secretary or whoever was. So also when you are an enterprise manager or something like that, you'll know that Windows NT in particular had some edition of Windows NT server, which was named Enterprise Edition, and that one would be more or less in the Windows 2000s time name Windows 2000 Advanced Server. And of course, companies would use sometimes, as I said, Windows 98 to print something from the network. Like they would use a Windows workstation to host a small web server. But the equivalent of Advanced Server was not unified with XP. And the Windows XP-like server and workstation would be with Windows 2003. But anyway, this is just maybe splitting hairs, but it's important to know that Windows XP was whatever Windows 98 was before. Another part.
In Windows ME, there were a few minor improvements. For one, it dropped support for real mode DOS, a legacy specification from back when 1 megabyte was a lot of memory, which in effect made the system boot time significantly faster, even faster than 2000 by some reports, with recorded times as low as 20 seconds to get to the desktop. At the same time, this decision also made the system much more stable compared to previous 9X versions of Windows, at the cost of lessened support for DOS programs.
Okay, so this is partially true, partially not true. So probably the critical part is to understand the architecture of Windows 95, 98 and Windows ME. But what you can see, and there is a clip here, and the clip is 43 seconds. But what is the most critical part? You will see that after the post, or how it's named, the BIOS initializing, at around second 18, it will start booting. And it's a Pentium 133. So from second 18, so it's already starting. And you'll see that it will boot in 18 seconds. So how is it this possible? It is simply that Windows ME simply skips just one step out of 6, if I recall right, of real mode. And people who don't understand how Windows 95, 98 or Windows 3.1 or 3.0 was, it initially started a MS-DOS version, and the DOS is a very limited operating system which gives you a command terminal and it can launch one process. So Windows was started with a command win.com, which was a command specific type of executable, and this one will fill up Windows. So Windows 95 would allow you to set up drivers before, like Smart Drive, it will be one of them. It was not mandatory because Windows 95 had its own caching, but you could, if you are careful enough and you'll make sure there is no conflicts with ports with IRQ, it will boot very fast to the earlier versions. And you could do it, as I said, with a lower spec machine even. Also, this is a quite interesting claim, and this will be the most of the clip.
Windows NT. One of the consequences of NT's portability goals, however, was that it didn't run nearly as efficiently as Windows for x86. Being written in C, it was easy to port the code to different architectures, but it meant that generally the code wasn't optimized nearly as much as it could have been, had it been designed with just one processor in mind. This meant that, upon release, Windows NT 3.1 required much higher specs to run than its companion Windows version at the time. So, Microsoft directed NT towards the higher-end crowd, enterprise systems, servers, and other computers that could easily run Windows NT, while consumer PCs would run the lighter DOS-based Windows.
Yes, so this is a lot of nonsense, in my view. But let's fall back a bit. So one part which you should really consider is that you could see it's quite hard to find. But you could see like even on the same application, and this is a very user space heavy application, that NT was running faster. It's by 3%, but you could see more benchmarks that Windows NT in fact would run faster. And how it will be this possible if it was not optimized for the processor or something like that? Obviously, the year is around 1997. It was before Windows 98 or 2000. But the main part it was that Windows NT was very well optimized, and I'm not even saying anything but it was better optimized than the optimized in assembly Windows 95 or whatever. But also one part which you should take into consideration, it is that an operating system is a multiple factors testing. So for example, in AnandTech, it was showing that at least for one set of tasks named Office Bench 2001, make sure that in this graph is not zero based, so it's cut from 10. But Office 2000 had a very different behavior compared with Office XP. And you could see that even when you think that Windows XP it is optimized or it was optimized, it was that Windows NT4 was definitely the fastest. It was faster than Windows 2000 by significantly few seconds, like let's say around 13 in the simplest task versus almost 20 with Windows XP. But Windows XP was better, but you could see that it was true for like 70 seconds for Windows 2000, and only in multitasking the Windows 2000 and XP were in the same ballpark. So this is what one part of benchmark. The other part is that Windows NT by default was using NTFS as an option. You could choose FAT32, but typically it will be faster with an asterisk. And why it is? Because it was less prone to fragmentation, and there are more reasons why, but FAT32 it's faster to access in a way as CPU is concerned, because you need less to check for permissions. But after you do that, typically the FAT32 is more prone, for example, especially for fragmentation, which in long running sessions will make it faster to run the NT-based system. Obviously, after you defragment, the difference reduces drastically, but this is one other part which many people miss. But let's talk why Windows NT is slower, and I would use some diagrams which were a manual for IPX card, if I remember right, software one. It's not important even what IPX is or something like that. But on the left is the diagram how Windows 95 would look even to ME. So the hardware starts, initializes device drivers, and after the kernel starts, it has just three things running. There is a file system, there is a configuration manager, and some memory manager. And all this kernel runs in one process. And because it runs in one process, it doesn't have isolations. So it doesn't have what NT has, like services. The single service, as far as I looked and I found, it was the registry. The registry ran as a separate process which would communicate outside. But in NT, after your hardware starts, there is a microkernel that starts and it communicates everything with a separate process to the hardware abstraction layer, and separately it has some executive processes services, and all of them they use separate. My understanding they are separate processes, but it doesn't matter that much, but they are definitely isolated and they communicate through messages. And this is very specific architecturally, but it means that it isolates many more things. And on top of that, it has subsystems, and those subsystems run with different processes. And all these things mean many things. Like, for example, if you want to create a software router, a proxy, like in Windows 95, you'll run it basically on the kernel level. Maybe you'll have one process to run it. But if you crash, all your Windows crashes. In Windows NT, only the routing would crash. Your network would work as much as your proxy will not work. So, and this will be true for all the other components. And after you start all this part, which is typically a fixed cost in memory, and it depends on the operating system, like which versions of NT. After that, the operating systems run as fast as each other, with some differences which we will talk. So there are some misconceptions about C. So let's say you have a program and you think if you write it in C, it will run more optimally, especially it will use less memory, like this diagram shows. And this is absolutely false, because first of all, the term it will be transient. Let's say, for the sake of example, let's say in assembler it will use 100 bytes your function, and you exit out. And let's say for the sake of the argument, in C it will use 10 times more or 100 times more. Let's say it will use 1 kilobyte. It will use 1 kilobyte, but it will go back, it will exit the function, and the memory consumption remains absolutely the same. But in reality, especially C is very well understood to be more or less abstracting all the hardware. So if you write the code in C, even if we don't talk about optimizations, which compilers have, they describe very well a processor, no matter which processor, but it's very specific. And the single part you technically you could not do is that to make some optimizations that you don't have a specific instruction. But even this part, it is true that you could write in assembler Windows NT, and the critical functions were written in assembler in Windows. I know this because you can see even when Windows XP starts, you could see an optimized like SSC, sys, something like that, with specific instructions optimize typical functions of your Windows. So, and some people say this is true for Windows 2000 or XP, but no, it was true for forever. So and also games written fully in assembler, like Roller Coaster Tycoon or Diablo, if I remember right. They are fully written in assembler for most of parts, and they are running very well on Windows NT because you can write as assembly as you want. Obviously, it will not run on another CPU, and also critical parts of Windows were written in assembler. So let's talk about C and architectures and things like that. So let's imagine you have a DOS program. Another part which was very heavy is that you can see the kernel mode and how many layers are up to the point when you reach your Windows virtual DOS machine. So you see there are many abstractions which were technically slower because they need to communicate between each other through method calls, sometimes through copying, and you see you have a 32-bit to 16-bit copying of packets and so on, and there is the switch from kernel mode to user mode. So these are expensive, just to be very clear, and those one, especially if you run those applications, were very bad on NT, because very often in Windows 95 MS-DOS mode, you had right away access to your MS-DOS machine, and you didn't have so many directions to your Windows library. You really basically did a BIOS call. And this had both advantages and disadvantages, obviously. But especially for MS-DOS, like switching video modes or things like that, sometimes they will not even work at all because you don't have access to hardware in NT mode. But in MS-DOS mode, you'd have sometimes access to hardware to call an interrupt and to switch with random video mode, which Windows NT will not understand it, but MS-DOS would. So this is where most of the differences would be in real life. But on the opposite side, if you had a decent vendor-made driver for OpenGL, which was introduced with Windows NT 4 and then backported, if I remember right, to Windows 95 or DirectX, all of them they would work flawlessly in both NT or Windows 95, and sometimes they'll be faster, sometimes slower, but obviously for other reasons. So this would be kind of all, and I wanted to put at the end 2 clips, and the clips you should take them more or less like with a grain of salt, but I'm not sure if they are even crucial. Like you could find clips like when Windows 98 or something like that would boot on a Pentium 3 or something like that, because it's more lightweight, it would boot kind of in 1 minute, and this would be quite typical at the time. And I noticed on a very similar spec machine, it would boot in 40 something seconds. And again, the difference is not night and day, but this was a quite common case because Windows 98 would start drivers, would try to fix conflicts with plug and play, but they will do it first of all, I think, in MS-DOS mode, then in Windows mode. Then it was worse probably because of fragmentation or something like that. But in general, 1 minute for booting was possible when you compare that with NT. It's not that possible. I mean, it was possible too, but it was a fixed cost. So okay, so this is kind of all I want to say in this clip, but it's possible to find as I say, in a similar machines, similar booting times or something like that, and you shouldn't be shocked like because you see those times. Okay, So what can I show? So let's see this clip. I will go with YouTube. So this is a clip where right now it starts booting. Notice second 25, 26. So here it starts booting. So from second 30, and it boots, it boots, it boots. It boots, and it still refreshes, so it's not yet fully booted. And this was, if you look into the start of the clip, it was on a Pentium 3 at 700 megahertz, if I remember right. You'll have to pause it, but it's Pentium 3 at 700 megahertz. And let me mute. So here you can see Pentium 3 at 550. So it's similar machine. So here it takes some time to initialize the devices. So this is just detecting devices like SCSI drives. Obviously here are two SCSI drives like in ride mode, but Windows 98 would not properly support ride mode. Realistically, at the time, if I remember right, maybe I misremember it, but you had very big troubles. So right now it starts booting. Not yet, but soon. When the screen will turn a bit like 3, 2, 1, so basically minute 1, 30, 59. Okay, so from the 59, it will boot, and it will take, it's already kind of booted. But you can wait till the proper second. So obviously it boots faster also because it's a better hardware in a way. But to top it out, the operating systems were really different for different markets, and they had different architecture. That's why it felt a bit slower, and it would require a bit more memory. But it was not because of using assembler. Thank you. And from time to time I make clips about it in English only. So share it if you find it useful. And thank you. Bye bye.